So here is the last of the gap fillers. So let's review what we've done so far. So we started with a logistic differential equation and we broke that thing down. The second one that we did dealt with an area between curves, a volume, and a perimeter, right? We've also looked at one where there was a non-separable differential equation where we had to implicitly find the second derivative, do a second derivative test, do L'Hopital's twice on the third part, and then Euler's method on the fourth. My last gap filler is going to be here. And it's not even, well, we'll get to it. So they're giving me a function here. It's defined by this. So let's go. So we got a rational polynomial here. Find the slope of the line tangent to the graph of f at x is equal to 3. All right, so they want me to take the derivative of this and plug in 3. Now, we're BC students, right? We're BC connoisseurs. We don't need to do the quotient rule on this. Let's just rewrite this into a product. Do the chain rule and clean it up. Do whatever way you're comfortable with, though. It's not going to take that long in any method that you use here. I just like to put it here. So let's do f prime of x. All right, I'm going to start with my 3. I always tell students in the chain rule, chain the innermost derivative out and just keep working inside to out. So I would chain out a 4x minus 7. And then the global function is what? 3x to the negative 1. So we have to take a derivative of x to the negative 1, which is a negative 1, x to the negative 2. So again, we're going to bring in all pieces of the inner chain with it. So negative 1 times parenthesis 2x squared minus 7x plus 5 all to the negative 2. I would clean that up. Now I'm not going to expand this top, right? The negative and the 3 all times the 4x minus 7 all over, so that takes care of that, all over the bottom squared. So to get f prime of 3, remember this is number 5, so we're not going to get a calculator, so we've got to do this by hand carefully. And again, I'm not going to skip any steps. That's negative 3 times 12 minus 7 is 5. Parenthesis 18 minus 21 plus 5. Now remember, that's quantity squared. So that gives me a negative 15 all over negative 3 plus 5 is 2. 2 squared is 4. So my slope of f at 3 is a negative 15 fourths. Okay. Find the x-coordinate of each critical point of f in the interval from between 1 and 2.5. Classify each critical point as the location of a relative min, relative max, or neither. Justify your answers. All right. Critical point, fundamentals. Let them know we want to find f prime of x equal to 0. All right. Now look at my factored numerator here, right? So this equals 0 only at 7/4. At x equals 7/4. On 1 less than x less than 2.5. There is no other critical value to even evaluate. That's why I hate when they write that sometimes. They've done this on numerous past FRQs where it says of each, and some students might get confused, and I always just say be confident in yourself, know what you're doing. All right. Now, do you really think they want me to take another derivative of this, find the second derivative at 7/4, sign, and then do a second derivative test? I mean, that was my first thought. But then I was thinking, well, wait a minute. They're never going to make me do a bunch of crazy things all the time. Not this early, maybe. So can't we just do an f prime number line? Start at 1. Put in my 7/4. I don't even care about the scale on this. and then put in the 2.5. Look, this thing is already factored out. The bottom's always going to be positive. Now, should we have checked to make sure 7/4 doesn't make this 0? I'd guess. I'd hate that they would design a question like that. But they don't. So let's check let's just do a number line, all right? So if we plug in, so this is 1 and 1.75. If we plug in 1.5, we get a negative times a negative is a positive, and this will always be positive if it's not 0. So positive over positive is positive. It's got to change sign. There's no multiplicity that's even on that top factor. So I know this is going to switch to a negative. Now you can check 2 in here, right? That'd be positive times a negative all over a positive would be negative. So we know the derivative is changing from positive to negative at 7/4, so I have a relative max. Pretty simple, a lot easier than doing all that out by hand, right? Be on your toes. At x is equal to 7/4, let's start using some of their words. F has a relative maximum. Because f prime changes from positive to negative, at this point. Done. So it was more efficient to do an f prime number line analysis than it was to do a second derivative test. You could do it either way. I've done it both ways on this one. And it was obvious this was the faster way. Using the identity that that is equal to that. All right, so they didn't even make me do partial fraction partial fraction integration on this. They split it for me already. They want me to evaluate the integral from 5 to infinity of f of x or show that the integral diverges. All right, so I need to take this improper integral and evaluate it. So upper limit is of the integrand is infinity. So the limit as b approaches infinity, so we're going to rewrite this, of the integral from 5 to b of, let's substitute in the split out common denominator, so they undid it. And that's nice they did that for us already, but you can see it all became an improper integral problem. Just be careful here. I mean, I don't know how good you are at, or how much practice you have at integrating this type. It's not just 2 ln of that. There's a substitution adjustment that needs to be made here. Just be careful. I mean, if you want to write out the work to show it, that would be 2 dx, which means I needed to do a half du to adjust it to a dx. But there's a 2 in the numerator, so this would actually equal 1/2 times 2 times the integral of 1 over u du. All right, so just be careful on that. So that means those cancel out. I'm just left with 1 over u. So this becomes a limit as b approaches infinity. Now I'm going to set it up into my FTC bracket. This just becomes the ln of the absolute value. Now we don't need absolute value because we're going from 5 to infinity. So we're not going to have any domain issues. So I'm going to get rid of the absolute value. And that will be minus, and this one's easy, the ln of, there's no adjustment when we do our substitution for this one. Oh, and again, I don't need my absolute value for that. And that's going to be from why did I put 0? So from 5 to b. I think it'll be easier, and I'm sure you're yelling at me when I'm writing things down. So limit as b approaches infinity, sorry. I need to use some log simplification properties before I evaluate this limit. It makes sense to me that I would combine this as the ln of 2x minus 5 all divided by x minus 1. It'll just be easier to do an end behavior model as when I plug in b into my FTC. All right. We're not ready to drop our limit, right, until we take the limit as b approaches infinity. Now remember, I have not plugged into this thing yet. So this becomes the natural log of 2b minus 5 all over b minus 1 minus, now when I plug in 5, I get 5 over 4, so the natural log of 5/4. Now I'm ready to evaluate this limit, right? The end behavior model of what's being plugged into the ln is 2b over b as b approaches infinity. So that just becomes the ln of 2. Minus the ln of 5/4, and you probably would be okay to leave that, but we can get this all back into 1 ln now. It would be 2 divided by 5/4 in here, which would be 2 times 4/5, which would be the ln of 8/5. So we're showing what that is right there. I apologize. Sometimes I'm talking too fast, but at least I caught that pretty quick, obviously. All right, last piece. Determine whether the series, which is, look, instead of the x, it's just n goes from 5 to infinity. So they're just comparing the infinite sum to the discrete sum. Converges or diverges. State the conditions of the test used for determining convergence or divergence. We already did an integrals test already. I'll show you the other method you could do. Well, I won't show it, I'll talk to you about it, but what a waste of time that would be. All right, because the integral from 5 to infinity of 3 all over 2x squared minus 7x plus 5 dx converges, and you could just leave it at that, but I'll say converges to ln of 8 over 5. That means that the sum as n equals 5 to infinity of 3 all over 2n squared minus 7n plus 5 converges by the integrals test. We proved it. That's what we did there. And an integrals test would help you set up your harmonic p testing, right? So now the other route you could have taken was you could have done a comparable, right, to 1 over n squared. You know 1 over n squared from 5 to infinity is going to converge, right? So then you would prove that you would do a comparable or comparison test, which would be inconclusive. So you would then have to go to a limit comparison test to show that because the comparable 1 over n squared from 5 to infinity converged, and you would have shown the limit as n approaches infinity of that ratio of the comparable to this equal to constant, you would then be able to say that this one had to converge by the limit comparison test. What a waste of time that would be, but if you have the time and that's all you know how to do, then do it that way. All right, I hope this rewind helped you out, right? Some interesting stuff, some gap filling stuff, man. Keep going and try to get the best score you can.